Welcome to the Explainer. Today we're diving into an AI that's tackling a challenge that, honestly, has stumped even the brightest folks in programming, taking a dense scientific paper and turning it directly into working code. Just think about it for a second. An AI that can actually read a research paper, understand all the complex math and methods, and then just build the software it's describing from scratch. And look, this isn't some far-off sci-fi dream anymore. This is a real-world test for today's most powerful AI. It's a test that requires more than just coding. It demands deep reasoning, strategic planning, and some seriously sophisticated problem-solving. So, where are we at with AI's coding skills right now? To really appreciate just how big a breakthrough this is, we first have to understand the fundamental wall these systems have been running up against. The truth is, there's a massive performance gap. On a test designed for this exact skill, even a top-of-the-line AI agent scores around 42%. But human experts, we're talking PhDs here, are hitting 72%. That is a huge difference in ability. So why the struggle? What's the deal? Well, it pretty much all comes down to one core problem, what's known as the information bottleneck. It's the sheer volume of information in a paper versus the AI's limited ability to process it all at once. Think of it like this. You're trying to pour an entire ocean of information through a tiny little funnel. That funnel, that's the AI's context window. You simply can't cram everything in there at the same time, so, crucial details are going to get lost. And this information traffic jam, it causes some big-time errors. The AI might completely forget a key requirement it read on page 3, or it'll create two different code files that totally contradict each other, or sometimes it just writes code that flat out doesn't even run. So to solve this, you can't just throw more power at the problem. You need a completely new approach. And that's where DeepCode comes in. It's a system designed specifically to manage this information chaos, not just try to brute force its way through it. So instead of just trying to build a bigger funnel, DeepCode is all about managing the flow of information itself. It treats the whole thing like an optimization puzzle. How do you squeeze the most important signals through that tiny bottleneck while strategically filtering out all the noise? And this just completely reframes the problem. See, DeepCode isn't just another, bigger AI model. It's a smart, systematic framework for turning messy, unstructured knowledge into functional, reliable code. Okay, so how does this all work in practice? Well, it's a 4-part system that methodically deconstructs the problem and tackles that information bottleneck head-on. DeepCode orchestrates these 4 strategic operations to basically control the flow of information from the paper all the way to the final code, making sure nothing critical gets dropped along the way. First, it kind of puts on its architect hat. It reads the entire paper and creates a detailed blueprint. This blueprint captures all the really critical stuff, the project structure, the dependencies, the core logic, and it filters out all the narrative fluff. Then, as it starts writing the code file by file, it keeps this compressed summary of everything it's already built. They call it code memory, and it acts like the AI's short-term memory, preventing it from making contradictions and making sure all the different pieces of the software actually fit together. And here's the final and maybe most brilliant part. It doesn't just write code and hope for the best. Nope. It actively tests its own work in a safe environment, finds the bugs, and then uses the error messages as direct feedback to fix itself. It's all done in a closed loop. So the big question is, does this sophisticated strategy actually pay off? I mean, it sounds great in theory, but how does it really perform when you put it to the test? Let's look at the data from the PaperBench benchmark, which is designed specifically for this kind of task. The results, frankly, are pretty telling. When you put it up against other AI agents, it's not even close. DeepCode scores nearly 74%, which is a 70% relative improvement over the next best model. This just goes to show that its structured, systematic approach is way more effective than just relying on a powerful language model by itself. It also just decisively beats the leading commercial coding tools. And what's really interesting here is that DeepCode used the exact same underlying AI model as these other tools. That proves that its advanced architecture is the real key to success, not just raw horsepower. But this is the most surprising result of all. When they tested it on the same subset of papers, DeepCode's average performance actually surpassed the score of PhD-level human experts from top universities. Yeah,
On a task designed to be a huge test of coding and reasoning, a domain where we humans have always thought we had the edge, DeepCode came out on top with a score of 76.7%.
What this signals is that we're really entering a new era here. This isn't just about making coding a little bit easier, it's about fundamentally accelerating the pace of scientific discovery itself. And this raises a final, really provocative thought. If an AI can automate the painstaking process of turning theory into practice, systems like DeepCode could free up human researchers to focus entirely on dreaming up the next big idea. We might be on the verge of a fundamental shift in the very role of a scientist.